Hello everyone, good day. I hope everyone is well. Today we will discuss on a new lesson which is all about cutting heavy metal. So today we will focus on cutting heavy metal. In our previous discussion with our other classmates, we have been learned several lesson. We have learned uh, lesson which is also related to this topic, which is cutting heavy metal. Basically, uh, our goal is to understand heavy metals and to provide examples of heavy metals, and of course, to determine the process of cutting metals. So, before we are going to start with our discussion, I have a motivation. So to give you, uh, it's like a motivation which will guide you or make you predict on our lesson today. All right. So I know that you are familiar with the game Four Picks One Word because this game was very famous during my grader days. I have installed this game in my phone too. So our game is Four Picks One Word, and the mechanics of this game was that you I will show you four pictures, then you are going to guess the word which you think define the four pictures. So the first pictures is this. So what do you think the word is being illustrated in this picture? All right, so very good. So this word shows cutting. Another one. How about this one? How do you illustrate this picture? Nice. It's heavy. And last one, actually these are elements that we can see in our periodic table, and we can also see this in our surroundings. And what do you think are types of elements is this? Wow, excellent. So this is metal. All right, so to introduce to you our discussion this morning, so we will define metal cutting. So it is the process of removing unwanted material in the form of chip from a block of metal using cutting tools. So when we talk about metal cutting, it is a process where you are going to cut where you are going to remove something, or you are going to cut or divide. For example, a reinforcement bar, if you are going to divide it into four, and you are using a device which you can use to cut or to divide the tool, and that process is called metal cutting because you are cutting the metal, you're dividing the metal through the process cutting. So why do you think it is essential? Why do you think metal cutting is essential? It's because uh, it processed throughout engineering, design, and manufacturing industries, and also to increase the efficiency and reduce cost. So there are many types of metal processes, but uh, you think that metal process is would make your work easier because it processed through engineering and you have been following. It's like a research where you are following scientific method. You are following the methods well, where you can really divide or you can really follow the steps on cutting metals. So before we are going to discuss further on metal cuttings, we will first discover the history of why this metal cutting has been being equipped and used in many Filipino people or even foreigners. Mostly, a lot of engineers has or engineer or mechanical engineers or other mechanical mechanicist, mechanicist has following this one. So it's all start the history of metal cutting starts all from Egypt, where they use bowstring to drill holes in stone. So the first uh, metal cutting that they have been used was the bowstring, which is used to make holes on stones. For instance, um, kanang mga manual nga galingan or manual milling, which is used in our kanang mga ninuan natin noon. They use stones, and the process of uh, making a hole on those stones are called drilling, and it's part of metal cutting. But first, they have been discovered it through stones. So we have here the table which shows the history of metal cutting. So during the Stone Age, where there are no metals discovered yet, so they use the mechanical methods were first adapted for material removal. So they use mechanical methods which they have adapted uh, to remove materials. So at early 4000 BC, they used the rotating device, which I just told you, the bowstring, which is used to drill in stones. And in the mid 19th century, they have been following the scientific work in metal cutting. And in 1870 to 1873, the first attempt to explain how chips are formed. So basically, the chips formation and its phenomenon. And in 1881, Mallock emphasized the importance of shearing and friction on work-tool interface. And in 1883, they observed effects of cutting lubricant. So there is progress from Stone Age up to the present, no? So we can see that there is really progress in terms of metal cutting or the process of cutting metals. So there are types of cutting processes, operations, or we call that operations, cutting processes or the operations. So machining is not just one process. It is a group of processes too. So we have observed that machining is very relevant nowadays and is very kanang useful in terms of cutting lubricants and metals. So there are many kind of machining operation, each of which is specialized to generate a certain part, geometry, and surface finish quality. So there are many cutting processes where each of them has their own role. For example, a grinder, which is used for drilling, mainana bitaw. So each of this device has their own kanang role. Na sila role sa pagkat sa metals. All right. So here are some of common cutting processes. So basically, here is the straight turning, the cutting off, the slab milling, and the end milling. So far from that, we have also other cutting processes, but here are four only. So first, we will focus on turning. We will discuss on turning. So here is the illustration of turning. So what is turning? So it is used to generate a cylindrical shape. In this process, the workpiece is rotated and the cutting tool removes the unwanted material in the form of shapes. So when we talk about turning, basically the word itself turning means turning or a cylindrical shape. So you are making a cylindrical shape. So its process was uh, the workpiece or kanang metals nga imuhang ganahan nga i-cut or ganihan imong i-process is turning kanang it's turning, and the tool or the device which is used were kanang stable siya. And then the materials or the parts that is unwanted or you want to remove are being removed. So that process is called turning. Next one is drilling. So maybe the word drilling is very familiar, or I know that you are very familiar with the word drilling because this is very relevant nowadays and is being applied and used by most people in the world. So it is used to create a round hole. In this process, the cutting tool is rotated and feed against the workpiece fixed in holding device. So uh, at this time, the workpiece is stable or stay, would not move. Rather, the drilling machine or the device will uh, will work or rotated in order for the workpiece or the metal to be cut or to have hole. So that is the function of drilling. It's to create a round hole on a machine. Another one is boring. So boring is used to enlarge an already drilled hole. It is fine finishing operation used in the final stage of product manufacture. So when we talk about boring, it is applied after drilling. So when the hole is, I mean, when the metal is being drilled already, so you can now apply drilling, boring, because boring is just used to enlarge an already drilled hole. So it's like finding the hole, or in the final stage, it is applied in the final stage of product manufacture or in the metals. So following up is milling. So milling is not just applied in milling rice and grains and corns, but also it is also applied in uh, cutting processes or metal cutting processes. So this process is used to remove a layer of material from the work surface. So milling, from the word milling, so it is used to remove a layer of materials. For example, if you're going to make different shapes from your metal, if you are, for example, kanang mga metals nga nice shapes inana. So that process is called milling, where the work where the material from the work surface, so it is used to produce a cavity in the work surface. In the first case, it is known as slab milling, and second case, it is known as end milling. So first, the first process is called, in the process of cutting metals in milling, was the slab milling, which is kanang first used, and afterwards they discovered, or we will apply the end milling, or in the second case. So another one is the cutting off. Cutting off is used to cut the metal into two parts. In this operation, the workpiece is rotated and cutting tool moves radially inward to separate the components. So cutting off, it's like you're just cutting. So from the word itself, cutting off, so you are cutting the metal, where the workpiece or the device will move, kana siya mo move in order for the metal to be cut. So here is the process. So na mga different types of cutting materials or cutting device which involve cutting off nga pwede nimong gamiton to cut metals. For example, this is a cutting saw, where it is only applicable for some kanang lubricants or metals no nga makaya ra pud niya. So cutting saw has different sizes also, and you can use different sizes for different types of metals. So next is grinding. So I know that you are very familiar with this because I know that many of you has been faced or has been see or has saw people grinding. So grinding involves in smooth metal surface and very high quality. So a grinding machine has an abrasive wheel that turns while making contact with the metal. So wearing the surface down and helping separate it. So grinding basically applied when you want to smoothen the surface of your metal. And grinding also kanang are used in kanang make grinding bolos in shapes of your kuan blades, no? Gigamit ang grinding. So apply siya basically kanang it is used to smoothen the metal, no? Inana siya ang work or process of uh, other cutting processes, no? Ang grinding, which is basically very familiar and very relevant point and related nowadays. And next is the welding. So let's see on the picture. So welding is very common nowadays, and we have seen this in many people have been do to use welding, have been done welding. So welding or burning techniques involve application of high heat to the surface metal. So that is why we can see that when there is someone welding, we can see a spark of fire or heat. So those are because uh, they use the high temperature or high heat in order for the metal to be cut or to be processed. So it brings it up to temperature at which it will soften and then break along a precise line. So uh, welding will soften the metal at the same time it will also break or break or cut the line. So another one is flame. So maybe flame is not very that common, and we have not seen this in people who are doing. However, flame is a gas that reaches a temperature of above 3,500 degrees Celsius. Um, so flame, the word is a flame, so it uses flame. So, kung anong mo, no? If you're going to think how heat or how high was the temperature is being used in just to cut the metal. So it used at least above 3,500 degrees Celsius, no? And this heats the metal to melting point. So uh, the heat or the temperature of the device will or the flame will melt the metals and it will break or it will separate. So then directs a stream of oxygen onto the spot, causing the metal to burn and melt along a line. So if you have made a line and you're going to cut using the flame, so you have really has to use at least 3,500 degrees Celsius, which is now applicable. No, applicable na siya nga gagamiton in order to cut or to remove or to break or to melt the metal. So inani siya ang picture. So makita ninyo nga na ay device and the devices flame. And makita po nato diri sa pictures nga ang metal is melting, no? So another one is laser cutting. So laser cutting is relatively similar using concentrated beam. So laser cutting is like it's like similar to flaming because from the word laser, so you are using laser, and it involves also a high temperature or yeah, a very high temperatures, and there the laser is being kanang controlled by a computer. So in order to get a maximum accuracy. So for example, a laser gi-control siya sa computer, and for example, if you are going to uh if the metal has the melting point of 4,000 degrees Celsius, so you can put that high temperature by controlling the laser with a computer. So inana siya. And another one is a plasma. So a more recent technique is plasma, which uses plasma torch to pump either oxygen or insert gas out of the nozzle while simultaneously sending the electrical arc through the gas. So this creates plasma hot enough to melt metal while moving quickly enough to blow metal molten away. So uh, plasma, so in plasma cutting, you have used the plasma, which you will use the torch of the plasma uh, or either the oxygen. So you can also insert gas sa nozzle niya, then you are sending also electrical arc. So in that process, the metal will melt, no? Ma-melt siya. All right, so this is the process of plasma cutting gas. So here, kanina sa pinakataas is the plasma cutting gas, and this one are the electrolyte. Here is the gas shield or the shield gas and the nozzle where the plasma gas flows and swirl. So we can see the kaning white gas spiral. So ang plasma gas mo flow siya diya into patterns around the electrolyte kanang naka-brown and through the nozzle. So the nozzle orifice swirl ensures proper arc attachment point. All right. So next one is the water jet. So it is a erosion technology mimic the effect of water on metal in the natural environment, just at much higher rate. So in metal cutting processes, you kanang there are process nga which is not just involving kanang using high temperature but also or higher temperature, but also here in this process we are using water. So the effect of water on the metal in the natural environment just at much higher rate. So this method doesn't rely on any heat. So yes, very kanang sabutable no nga water jet from the word itself, from the name itself, water jet. So they use na jud siya water, and therefore it doesn't need any use of kanang heat or high temperature because uh it can be used on metals that are sensitive to high heat. So pwede nimong gamiton ang water jet to those metals nga sensitive sa high temperature. For example, katong mga metals nga dali kayong malanay, no? Kanang mga alloys nga dali kayong malanay. For example, those example ana nga mga metals, no, nga pwedeng malanay dayon. So imong gamiton is the water jet. So the source of water or the reservoir here, and the pump for supply water. So the pump will supply water to the intensifier. So the intensifier will increase the pressure of water, goes to accumulator, and the accumulator or the control valve will control the flow of water, and the flow regulator will regulate the flow. The nozzle to increase the kinetic energy. So again, the process of water jet was here. So you have the reservoir, which is the source of water. Murag tangki bitaw nga na din ang tubig. So mao na siya yung source sa water. And also napo kay pump or water pump, any pump nga pwedeng maka-supply sa water, which will makes the water move through intensifier. So the intensifier will increase the pressure of water, and then the water from the accumulator will flow to the control valve, and the control valve will control the flow of water. And the flow of or the water goes down to the flow regulator, which will regulate the flow of the water, and the nozzle will increase the kinetic energy or the Ka. So here is an illustration. Inana siya. So kanina atin makita nato nga water na siya, and here is the nozzle. Kanina dapit sa yellow. So aside from those process, we also have the metal cutting methods, the orthogonal cutting process or the two-dimensional, and the oblique cutting process. So are you familiar with this process or this method? Well, I guess if not, so we will tackle on this one. So orthogonal cutting process, it is a process where cutting edge is perpendicular or 90-degree to the direction of feed. The shape flows in a direction normal to cutting edge of the tool. A perfectly sharp tool will cut the metal on rock surface. So, ang orthogonal cutting process inani siya. So kanina ay nakabutang nga workpiece, so that is your metal. So kanang nay nakabutang nga feed, so ang makakinaon sa metal. So for example, kaning tool nga imong gigamit or a device mo na siya dinha. F1 dayon, ang F2 mo na siyang imong feed, 90 Celsius ang yahang 90 ang iyang gamiton. So ang kaning mga kinaon dinhi mapunta aning tungod sa F2. So next is the oblique cutting process. So in oblique cutting process, the cutting edge is inclined at acute angle. So ang iyahan sa oblique is acute angle, so less than 90 . So when we talk about orthogonal, it is perpendicular and which use the 90 to the direction, while ang oblique less than 90 to the direction of feed. So wala siya kabot og 90 ang puntahan sa ship or the feed. So the ship flows sideways in a long curl. The chip flows in the direction at an angle with normal to the cutting edge. So inani ang process sa oblique. So ang tool is less than 90 ang iyang formation, workpiece. So inana siya. And now, we will kanang discover the difference between orthogonal and oblique. So, here are the bases, the 2D or the 3D cutting process. When we talk about 3D process in orthogonal, it is two-dimensional cutting process. While in oblique, it is three-dimensional cutting process. Ortho means Ang orthogonal means ang iyang dimension sa 3D cutting process is 2, while the oblique is 3. Kung mingon putang sa cutting edge and direction of feed, sa orthogonal, it has the tool remains at 90 degrees to the direction of feed, while in oblique, the the cutting tool remains inclined at an acute angle to direction of feed, so or less than 90 degrees. So the direction of chip flow, so the chip flows in a direction normal to the cutting edge of the tool, while in the oblique, the chip flows in the direction and the angle with normal to the cutting edge of tool. And the components of cutting forces, so there are only two manually perpendicular components of cutting forces acting on the tool, so sa orthogonal. While sa oblique, there are three manually perpendicular components of cutting forces acting on a tool. So sa orthogonal na ay tulo ka forces nga mo'y murag ni support sa tool, while sa oblique na siya'y tulo. And the heat developed due to friction. When we talk sa orthogonal, during the process, the heat developed due to friction per unit area is more, while in the oblique, the process of the heat will develop due to the friction per unit area is less. So, ang life or the span sa tool sa orthogonal nga process, the tool life is smaller than obtained in oblique cutting for some same cutting condition. For example, kung pareho silang condition nga gikat. So sa oblique, tools have longer life. So kung mayroon kang orthogonal cutting process, so ang imong device, kung orthogonal ang imong buhaton, so ang imong device dali ra gyud na siyang madaot or mubo ang iyang lifespan. While sa oblique, tuod-tuod jud siya. Shear force, the shear force acts on a smaller area, while on the oblique, the shear force acts on larger area of cutting edge. And the relation between cutting edge and width of cut, so the cutting edge is bigger than the width of cut, while the oblique, the cutting edge is smaller than the width of cut. So look at the figure. Look at the figures between orthogonal process and the oblique cutting process. So inani ang formation niya, no, ng workpiece dayon ang chip na 90 degrees siya, and the cutting tool ni nanarag yun ang forma, unlike din sa oblique. So next up is we will define on heavy metals. So heavy metals are defined as metallic elements that have a relatively high density compared to water. So with the assumption that heaviness and toxicity are interrelated, heavy metals also include metalloids such as arsenic that are able to induce toxicity at low level of exposure. So when we talk about heavy metals, that's are actually elements that we can see in the periodic table of elements that has high density or that has high atomic mass or mga bugat sila. So some examples of heavy metals are copper, selenium, iodine, zinc, mercury, and magnesium. So aside from that, we will define what is arsenic, which is an example of heavy metals. So arsenic is one of the most important heavy metals, causing discomfort from both ecological and individual health standpoint. So arsenic is one of the heavy metals pud ni siya. Next one is lead. It is a chemical element with the symbol Pb and atomic number 82. It is heavy metal that is denser than most common materials. Lead is soft and malleable and also has a relatively low melting point. When freshly cut, lead is silvery with a hint of blue. It tarnishes to a dull gray color when exposed. So, ang lead different siya sa uban nga metals kay ang iyang melting point is kanang longer or mas dugay siya nga ma-melt. For example, if you will use kanang flaming processes to cut kanang lead, maglisod gid ka kay kuan man dugay man siyang ma-melt. So inani ang itsura sa lead. Next is mercury. It is a chemical element with the symbol Hg and atomic number 80. It is commonly known as quicksilver and was formerly named hydrargyrum. So, mercury, yung symbol is Hg, and we can see its atomic number in the periodic table, which is 80. And mercury is commonly kanang associated with the color silver. Nuinan ninyo ang mercury. Next up is cadmium. It's a chemical element with the symbol Cd and atomic number 48. So that this soft silvery white metal is chemically similar to two other stable metals in group 12, zinc and mercury. So ang zinc and mercury, they are look alike. Bitaw mga soft ni sila nga metals. Another one is copper. Copper is kanang relatively used in electrical wires. No, ang copper gamit na siya sa mga electrical wires and others. So copper is mined in both open pits and underground mines depending upon the ore grade and the nature of ore deposit copper. So ore typically contains less than 1% copper in the form of sulfide minerals. So once the ore is delivered above the ground, it is crushed and ground to a powdery fineness and then concentrated for further processing. So this is copper. For example, kanang mga wires, hog wires, not hog wires, mga kanang wires bitaw nga gigamit sa kanang line up sa kuryente, padulong sa mga paniwalayan ana or houses or homes. So those kanang black nga wires is composed of wires or metal nga copper. Alright, so before I'm going to say goodbye to you guys, I'd like you first to watch the video of a plasma metal cutting process. This process is a thermal cutting method, which means that it uses heat to melt the metal instead of mechanically cutting.
If you're in the metalworking business, you've heard about plasma cutting systems. Plasma's combination of cut quality, productivity, and versatility make it one of today's most popular industrial cutting processes. But first, what is plasma? Plasma is often called the fourth state of matter. Let's take a look at the three other states we're all familiar with. They are solid, liquid, and gas. The difference between these states is their energy. When you add energy to ice in the form of heat, the ice melts and forms water. If you add more energy, the water vaporizes and becomes steam. From ice to water to steam. But what happens if you add even more energy to the steam? A lot more. If you could heat it to 11,700 degrees Celsius, the steam would break up into a number of component gases. It would also become electrically conductive or ionized. This high-energy ionized gas is called plasma. Plasma is created when you expose a gas to very high temperatures or when you pass electricity through it. Our most familiar form of plasma is probably the gas inside a fluorescent or neon light bulb. Lightning is an example of plasma on a larger scale. And on a very much larger scale, our sun and all the stars are also made of plasma. Plasma is quite remarkable. It has no specific shape. It's also a bit like a metal in that it easily conducts electricity and produces and responds to magnetic fields. Because of these unique properties, plasma can be tremendously useful, which brings us back to metal cutting. Now that we have a better idea of what plasma is, let's see how it works. Here's the inside of a plasma torch, the kind typically used on cutting tables. Compressed air, nitrogen, or other gases provide a source for the plasma. In this example, a second inert shield gas is used to protect the workpiece and blow off melted metal. The electricity supplies the energy needed to turn the gas into plasma. The greater the current, the hotter the plasma. A specially engineered nozzle and electrode constrict and maintain the plasma jet, concentrating it into a small area so it can be used for cutting. When the operator is ready to cut, a start signal is sent to the DC power supply. A circuit temporarily connects the nozzle to the positive side of the power supply with the electrode at negative. Next, a high-frequency spark ionizes the gas and makes it electrically conductive. This creates a current path between the electrode and the nozzle and forms a pilot arc of plasma. The workpiece is connected to a ground through the cutting table. When the pilot arc contacts it, the plasma arc transfers to the workpiece, melting the metal. The high-velocity gas blows the molten material away. And that brings us to the end of our brief journey into the fourth state of matter, brought to you by Messer Cutting Systems and our friends and